The lab report lands on Dr. Marcus Ellington's desk on a Tuesday morning in the spring of 1991. It looks like nothing. A single stapled printout. A few columns of numbers. The kind of document most researchers scan once and drop into a filing pile without a second thought. Marcus almost does the same thing. He is running on 4 hours of sleep. His coffee is cold. He has 47 emails waiting. But something in the numbers stops him. He reads the printout again. Then a third time. Then he leans back in his chair, presses both hands flat against the desk, and stares at the ceiling of his Baltimore laboratory for a long moment. The omega-3 fatty acid concentration listed on that page is not supposed to be possible. Not from a plant. Not from this plant. Not from a creeping, low-growing weed that covers sidewalk cracks from Atlanta to Seattle. Not from something that every homeowner in America spends money trying to kill. Hi viewers, before we go any further, drop a comment below and tell me, have you ever pulled this plant out of your garden without knowing what it actually was? The numbers in front of Marcus do not belong to a laboratory-engineered superfood. They do not belong to a cultivated crop funded by $1 billion agricultural research program. They belong to purslane. A plant so common, so ignored, so aggressively removed from American soil, that most people cannot tell it apart from crabgrass. And yet, gram for gram, this weed contains more omega-3 fatty acids than almost any leafy vegetable ever studied. More than spinach. More than kale. More than the foods printed on every government nutrition poster hanging in every school cafeteria across the country. Marcus sets the report down. He walks to his window and looks out at the parking lot below. There, growing in a thin strip of cracked concrete between two painted white lines, is a small, low cluster of smooth green leaves with reddish stems. He recognizes it immediately. Purslane. It is growing right there. It has been growing right there, in that exact cracked strip of concrete, every summer for the entire 4 years he has worked in this building. He has walked past it hundreds of times. He has never once thought of it as food. Almost no American has. But here is the thing that Marcus cannot stop thinking about as he stands at that window. The nutritional data he is looking at is not new. The first documented analysis of this plant's chemical composition was filed with the United States Department of Agriculture in 1923. 68 years before Marcus Ellington ever ran a single lab test. 68 years. The information existed. It sat in a government archive. It was printed in an official document. And during those 68 years, the very same plant that the data describe as nutritionally remarkable was systematically labeled a weed, targeted by herbicides, taught in agricultural schools as something to be eliminated, and quietly erased from the American food conversation. Not through accident. Not through ignorance. Through something far more deliberate. Marcus picks up the 1923 bulletin and reads the number 1 more time. He underlines it. He circles it. Then he opens a fresh notebook, writes a single question at the top of the first page, and draws a hard line beneath it. How does a plant this nutritious get classified as a weed? The answer will take him 3 years to find. And when he finds it, it will have nothing to do with science. It is August in Georgia. The air sits heavy and wet over the red clay fields outside Valdosta. A 9-year-old girl named Deja Lattimore is barefoot in her grandmother's garden, and she is eating. Not from a bowl. Not from the kitchen. Straight from the ground. Her grandmother, Erlene, is kneeling 3 rows over, her wide hands moving fast through the soil, pulling clusters of a low green plant and dropping them into a worn wire basket. The plant has thick, smooth leaves. Reddish stems that almost look like they were painted on. It spreads close to the ground in small star-shaped clusters, pressing itself flat like it is trying to hold the earth together from above. Deja chews a stem. It is cool. A little sour. Faintly sweet underneath, the way certain things taste when you eat them where they grew. Her grandmother looks over and nods, a slow approving nod, the kind that means you are finally learning something. That plant is purslane. And in Eileen Lattimore's garden, it has never been a weed. For centuries, communities across the world understood this plant the way Eileen did. Mediterranean farmers tucked it fresh into salads. Turkish grandmothers folded it into thick yogurt dishes. Mexican families in San Antonio fried it with eggs and green onions on Sunday mornings. North African villages in the Sahel gathered it during drought seasons, when nothing else would grow. It thrived in poor soil. It came back every year without replanting. It needed almost no water. It asked for almost nothing. To people who understood hunger, that made it precious. But America was building something different in the early 20th century. Agriculture here was not moving toward resilience. It was moving toward control, toward scale, toward systems that could be measured, managed, and sold. In that new world, a plant that grew without being planted was not a gift. It was a variable, a disruption. Something that showed up in fields where it was not invited and refused to follow the schedule. The Extension Service offices across the rural South and Midwest began distributing farming guides. These guides taught the new science of agriculture: soil management, crop rotation, chemical application. And in the back pages, in the sections on field maintenance, purslane appeared. Not in the food chapter. In the weed chapter. Deja Lattimore grows up and leaves Valdosta for Atlanta. She studies nutrition at Spelman College. She eats from supermarkets now, like everyone else. She buys omega-3 supplements from a glass bottle at the pharmacy on Peachtree Street. She has not thought about her grandmother's garden in years. She does not yet know that the plant she used to eat barefoot in the Georgia heat contains the exact nutrients she is now paying $11 a bottle to replace. Nobody told her. Because somewhere along the way, the people who were supposed to keep that knowledge alive decided the plant was not worth keeping. In a research lab at the National Institutes of Health in Bethesda, Maryland, a woman named Dr. Renata Simmons pins a printed chart to her corkboard and steps back to look at it. She has been studying infant brain development for 11 years. She knows the nutritional literature better than most people know their own family histories. She has read thousands of studies. She has cited hundreds of them. But she has never seen a chart quite like this one. The chart compares alpha-linolenic acid content across 17 common food sources. Alpha-linolenic acid is the plant-based form of omega-3. It is the fatty acid the human brain needs most urgently in the first 3 years of life, the window when neural pathways are forming, when language is wiring itself into the cortex, when the architecture of a child's thinking is being built, one fat molecule at a time. Renata's finger moves down the chart. Fish, flaxseed, walnuts, chia, spinach, kale. Then her finger stops. Purslane sits near the top. A common field weed. Outranking spinach, outranking kale. Delivering a concentration of brain-essential fatty acids in fresh leaf form that rivals plant sources at 3 times its commercial price. She unpins the chart and carries it to her colleague's office down the hall. He reads it. Looks up. Reads it again. They say nothing for a moment. The silence is not confusion. It is the specific quiet that researchers enter when data contradicts something they thought was settled. Beyond the omega-3 numbers, purslane carries vitamins A, C, and E in concentrations that rival vegetables costing $6 a bunch at Whole Foods. It is dense with magnesium and potassium. It carries antioxidants that nutritional scientists are still studying. And in a finding that surprises nearly every researcher who encounters it, purslane contains measurable amounts of melatonin. A sleep-regulating compound is rarely found in any plant food at detectable levels. None of this is hidden. None of it is classified. Every study confirming these numbers is sitting in publicly available journals. The data is real, peer-reviewed, and repeated across independent laboratories on 3 different continents. And still, purslane is not on the shelves at grocery stores. It is not in the USDA's dietary guidelines. It is not listed in school nutrition programs. It is not in the formula used to evaluate food access in low-income communities. It is, in every official food document in the United States, still a weed. Renata walks back to her office. She pulls up a file she started 2 years earlier, a folder of research on food access disparities in communities with high rates of infant developmental delay. Low omega-3 intake appears in that folder. Over and over again. She thinks about the chart. About the plant growing in sidewalk cracks 3 blocks from the NIH parking garage. She thinks about how long the data has existed. About who decided it did not matter enough to act on. She opens a new document on her screen and types a single heading at the top. Then she stops. Because she just realized the real question is not how purslane got ignored. The real question is who benefited from keeping it that way. The year is 1947. A man named Howard Brackett sits inside a Federal Agriculture Committee hearing room in Washington, D.C., and he is not nervous. Howard is never nervous. He is one of 3 senior advisors from a major chemical manufacturing company, and he has sat in rooms like this one many times before. The committee is deciding how to allocate post-war agricultural funding. Hundreds of millions of dollars. The question on the table is how America will transform its wartime production infrastructure into a peacetime food system. Howard already knows the answer they are going to reach. Because Howard helped write the question. The industrial transformation of American agriculture did not happen by accident. It was the product of deliberate economic pressure, research funding decisions, policy language, and infrastructure investment. Synthetic fertilizers needed to be sold. Chemical herbicides needed markets. New hybrid seeds, engineered to respond to specific fertilizers and chemicals, needed farmers willing to buy them every single year instead of saving last season's seed. Every piece of this system depended on one thing: dependency. A farmer who saved his own seed, managed his own soil fertility through rotation and wild plants, and harvested crops that grew without chemical input was a self-sufficient farmer. He was also a terrible customer. A farmer who needed to purchase inputs every year, who relied on corporate seed catalogs, who sprayed herbicides on every undesirable plant before it could spread, was a farmer locked into a recurring system of purchase. This was not a conspiracy sketched in a dark room. No single man planned it in one sitting. It was the natural result of economic gravity. Money flows towards systems it can control. Capital expands into markets it can repeat. And in the decades following World War II, American agriculture became one of the most profitable recurring purchase systems ever built. Agricultural universities received funding from chemical and seed companies. Research programs studied crops that needed management. Extension services trained farmers on input-dependent practices. Government subsidies favored high-yield commodity crops that required the full stack of industrial products to produce. And plants that required nothing? Plants that seeded themselves and spread without cost and grew in soil too poor for anything else? Those plants were reclassified. Not through a single dramatic vote. Not through one official decree. Through thousands of small decisions. A paragraph was added to a farm management guide. A line item in a research budget. A listing in an herbicide manual. A word choice in a textbook used to train the next generation of farmers. Weed. Howard Brackett returns to his company's headquarters after the committee hearing. He writes a memo. In the memo, he recommends a new product line targeting broadleaf field plants resistant to current herbicide formulas. He lists 6 target species. Purslane is second on the list. Words do not just describe reality. They built it. In 1850, no American farming manual contained the word purslane in a chapter on unwanted plants. It appeared in kitchen herbals, in wild food guides, in traditional medicine texts, in letters between colonial farmers trading knowledge about drought-resistant garden plants. It was food. By 1950, 100 years later, it appeared in herbicide company product literature under the heading, Broadleaf Weed. Target for elimination. 100 years. One word. Completely different world. A 16-year-old boy named Terrell Washington is sitting in an agriculture class in a public high school in Fresno, California, in the spring of 1968. His teacher is a good man. Thorough. He draws diagrams on the board in green chalk. He explains soil pH, crop rotation, and the importance of managing field competition. Field competition means weeds. Terrell's teacher holds up a laminated identification card. On it is a photograph of a low-growing plant with smooth oval leaves and reddish stems fanning out in a star shape across dry, cracked earth. The teacher taps the photo. Portulaca oleracea, he says. Common purslane. High germination rate. Spreads aggressively. Competes with root crops and row vegetables for soil moisture. Priority removal. Terrell writes this down. He does not write high omega-3 content. He does not write edible. He does not write historically cultivated across 4 continents as a food crop. His teacher does not say these things. Because his teacher's textbook does not contain these things. Because the curriculum was written using materials from agricultural extension programs. Because those materials were shaped by the same research funding priorities that Howard Brackett helped set 20 years earlier. Nobody lied to Terrell directly. Nobody stood in front of him and said, "Do not eat this plant." The information was simply absent. The word that replaced all other words was weed. And once a generation learns a word with enough authority behind it, the word becomes a wall. Terrell Washington grew up to own a small farm outside Bakersfield. He is a careful farmer. He manages his fields well. Every spring, when the rains come and the purslane pushes up through his topsoil in thick green mats, he applies pre-emergent herbicide to kill it before it can spread. He has done this for 31 years. He has never once tasted it. He does not know that the plant he is killing is carrying nutrients his children's bodies need. He does not know. Because the system that taught him how to farm made sure he would not. But language is not permanent. And the same generation that learned the wrong word is about to be confronted with a science that does not care what anything is called. Erlene Lattimore died on a cold Thursday morning in February of 2003. She is 81 years old. She dies in the same house she was born in, 12 miles outside Valdosta, Georgia, in a room that still smells like dried herbs and wood smoke. Her granddaughter Deja drives through the night to get there. She sits by the bed and holds Erlene's hand while the room is quiet and the rest of the family is in the kitchen making coffee and talking in low voices the way people do when grief is too large to fit inside silence. 3 days later, going through Erlene's kitchen, Deja finds a handwritten notebook. Spiral-bound. Blue cover. Inside, in her grandmother's careful cursive, is a list of plants. Wild plants. Garden plants. Plants that grew along fence lines and behind the barn and between the rows of okra and pole beans. Next to each plant name is a note. What was it good for? How to prepare it? When to harvest? Purslane is on page 4. Deja reads the note beside it. Erlene's handwriting says, good for the blood, good for the brain, best in summer, cook it light or eat it raw, do not waste it. Deja stands in that kitchen for a long time. The notebook is thin. Maybe 40 pages. It contains a working knowledge of plants that Erlene spent 80 years accumulating. Knowledge she received from her own grandmother, who received it from hers, a chain of women passing information forward through time, the way people pass names and recipes and the specific way to braid hair. And almost none of it exists anywhere else. Deja is a nutrition researcher. She has access to journal databases, university libraries, and NIH records. She has never been taught a single thing in her professional education about the plants in this notebook. Not one. The plants Erlene listed were not part of the curriculum at Spelman. They were not cited in the textbooks she studied. They were not in the dietary guidelines she learned to apply to patient care. They were not there because the institutions that built her education decided, generation by generation, that this knowledge was not worth keeping. No committee gathered to vote on it. No law was passed. No decree was issued. It was simpler than that. Agricultural schools stopped teaching about wild edibles. Seed catalogs stopped listing them. Grocery distribution systems never carried them. School lunch programs never included them. And slowly, the people who still knew, the Erlenes, the grandmothers with worn notebooks and dirt under their fingernails, grew old. And when they died, the knowledge did not always follow them out into the world. Sometimes it just stayed in the house. Deja carries the notebook back to Atlanta. She sets it on her desk beside her laptop and her stack of peer-reviewed journals. She looks at both for a long time. The journals were funded by millions of dollars. The notebook cost nothing. The journals took decades to confirm what the notebook already knew. Something is wrong with that. Deja is not yet sure exactly what. But the shape of it is beginning to come clear. And the more she looks at Erlene's handwriting, the more she understands that what disappeared was not just a plant. What disappeared was a whole way of knowing. Dr. Corin Ashby boards a flight to Athens, Greece, in the fall of 1992, carrying 2 bags and a research question nobody has been able to answer. He is a cardiovascular epidemiologist from the University of Michigan. For the past 4 years, he has been studying a data anomaly that keeps surfacing in international health surveys. Rural communities in certain parts of the Mediterranean are showing heart disease rates dramatically lower than what the risk factors predict. Low income, hard labor, high stress. They should be sick. By every statistical model Corin has built, they should be far sicker than they are. They are not. The data puts him on the plane. He spends 3 weeks in a village in the Peloponnese. He sits at the kitchen table. He eats what the families eat. He watches an 83-year-old man named Stavros walk 2 miles uphill every morning with the energy of someone 20 years younger. He watches women in their 70s carry full baskets from the market without breathing hard. He draws blood. He runs panels. He checks omega-3 levels. The numbers come back high. Not slightly high. Significantly, repeatedly, and almost inexplicably high for people who eat very little fish. Corin starts looking at the food. Not the meat and bread and olive oil that fill the center of every table. The greens on the side. The wild greens. The ones the women pick from the hillsides in the morning and bring home in their aprons. The ones that appear in every meal, chopped into salads, wilted into stews, stirred into soups. He photographs the plants. He brings the photos to a botanist in Athens. The botanist identifies them in under 10 minutes. Purslane, along with several other wild greens. But purslane is the most consistent. It appears in every kitchen photograph, every meal record, every dietary log Corin has collected across 3 weeks of documentation. He sends samples to a laboratory in Thessaloniki. The analysis comes back confirming what Marcus Ellington found a year earlier in Baltimore. The omega-3 content is real. The anti-inflammatory compounds are real. The nutritional density is real. Corin sits in his Athens hotel room and builds a timeline. The 1923 USDA Bulletin. Marcus Ellington's 1991 lab results. The Mediterranean dietary surveys from the 1960s hinted at wild greens but never named them specifically. The cardiovascular data from rural Greek communities stretches back 40 years. The evidence has been accumulating for decades. In different countries. In different laboratories. Among different researchers who never spoke to each other. All pointing at the same plant. A plant that costs nothing to grow. A plant that feeds itself. A plant that has been growing in the cracks of American sidewalks for 200 years without anyone in authority thinking to look at it twice. Corin published his findings in 1994. The paper circulates in academic journals. Some researchers cite it. A few journalists write brief articles. One small health magazine runs a short piece with a photo. Nothing changes. No grocery chain adds it to the produce section. No federal nutrition program includes it. No school lunch menu is updated. The herbicide companies that list it as a target plant do not change their product labels. The science said everything it could say. And the system heard it clearly. And kept moving exactly as it was. There is no villain in this story. That is the part that takes Marcus Ellington 3 years to fully accept. He spent the first year looking for one. He pulled USDA budget records. He filed Freedom of Information requests. He cross-referenced agricultural policy decisions with chemical company lobbying expenditures. He built a wall in his home office covered in photocopied documents connected by color-coded strings, the way detectives do in movies. He found pressure. He found influence. He found money flowing from corporations into research institutions in ways that shaped which questions got asked and which plants got studied. But he did not find a conspiracy. Because it was never a conspiracy. It was something more ordinary, and in some ways more troubling than that. It was an incentive. Every person who participated in Purslane's disappearance from American food culture made a rational decision based on the system they were operating within. The seed company executive who funded research on hybrid crops was not thinking about suppressing wild edibles. He was thinking about market share. The agricultural school professor who wrote the weed management textbook was not trying to erase traditional food knowledge. He was teaching the curriculum his institution had approved, which reflected the priorities of its funding sources. The farmer who bought herbicide and sprayed his fields every spring was not making a political statement. He was following the best practices he was trained to follow. The system did not need a central planner to erase purslane. It erased it automatically. The way any market erases things that cannot be packaged, priced, and resold. Deja Lattimore, now a practicing nutritionist in Atlanta, presents this argument to a room full of public health policy researchers at Emory University in the spring of 2004. She holds up her grandmother's blue notebook. She describes what Aline knew. She shows the nutritional data. She shows the timeline of suppression through economic incentive rather than intent. She makes the case clearly, carefully, and with every fact in order. The room listens. 3 people come up to her afterward with genuine interest. They talk for 40 minutes. They exchange cards. 2 of them later emailed her. Nothing changes in food policy. Not that week. Not that year. Because policy does not change when one room of researchers hears a good argument. Policy changes when enough pressure builds that the cost of not changing becomes higher than the cost of changing. And in 2004, the cost of ignoring porcelain is still zero for every institution that matters. But outside those institutions, something is shifting. The climate is shifting. The soil is shifting. The water is shifting. And plants that were designed by evolution to survive exactly these conditions are starting to push back up through the ground in places where nothing else will grow. Nature does not wait for policy approval. The summer of 2012 was the hottest summer on record across the continental United States at that time. Drought conditions blanket 60% of American farmland. Corn crops fail across the Midwest. Soybean yields collapse. The USDA declares drought disasters in more than 1,000 counties. In a cracked field outside Lubbock, Texas, a farmer named Dwayne Okafor walks the rows of his failed cotton crop in the early morning heat. The ground is gray and hard. The stalks are brittle. Everything he planted is dead or close to it. Everything except one thing. Spreading between the dead cotton rows in thick, low mats of green and red, covering the bare ground like a living quilt, is porcelain. Hundreds of square feet of it. Thriving. Pushing new growth in soil that has not seen meaningful rain in 11 weeks. Looking, Dwayne thinks, almost comfortable. He stands there for a long time. A man who has lost most of his harvest to the worst drought in a generation, standing in the middle of a field full of a plant his father taught him to kill. He pulls out his phone. He searches for the plant's name. He reads what comes up. Then he reads it again. He has never eaten porcelain in his life. He does not eat it that day. But he stops walking in the field with the intent to spray it. What Dwayne is experiencing in that Lubbock field is not unique. Across the American Southwest, across drought-stricken regions of sub-Saharan Africa, across degraded farmland in South Asia where industrial crops have stripped the topsoil bare, the same plant is appearing. Returning. Reclaiming disturbed ground with the quiet persistence of something that has been waiting. Agricultural researchers at land-grant universities who spent the previous 3 decades studying drought-resistant crop development are beginning to look at wild plants with new seriousness. The engineered solutions are expensive. They require infrastructure. They require inputs. They require water that is no longer available in the quantities the models assumed. The wild plants require nothing. A team of plant scientists at the University of Arizona published a paper in 2014 cataloging 12 wild species with exceptional heat and drought tolerance, and strong nutritional profiles. Porcelain is number 1 on the list. The paper recommends further research into the integration of wild edibles into food security programs for climate-vulnerable regions. It is the most formally official endorsement the plant has received from an American research institution since the 1923 USDA Bulletin. 91 years later. Marcus Ellington, now retired and living in Durham, North Carolina, reads the Arizona paper over breakfast. He sets his coffee down. He reads the paper twice. Then he walks to his backyard, where along the edge of his garden bed, growing in the thin strip of mulch between the wood border and the lawn, is a familiar cluster of smooth green leaves and reddish stems. He crouches down. He looks at it for a long moment. Then he picks a stem. And for the first time in 30 years of studying this plant, he puts it in his mouth. Cool. Faintly tart. A little sweet underneath. Exactly the way Deja Lattimore's grandmother described it. It tastes like something that was always supposed to be food. The blue notebook is still on Deja Lattimore's desk in 2024. It has been there for 21 years. The spiral binding is starting to come loose. She has kept it under a sheet of clear plastic to protect the pages. She picks it up sometimes. Not to read it. She has memorized it. She picks it up because holding it reminds her of something she wants to stay angry about. Not a person. At a pattern. The pattern of how a society decides what counts as knowledge. Whose knowledge gets written into textbooks and funded by universities and printed on government nutrition posters. And whose knowledge gets carried in a spiral-bound notebook and buried with the woman who held it. Deja is 52 years old now. She runs a community nutrition program in Southwest Atlanta. She works with families in neighborhoods where fresh produce is expensive and scarce, and where diet-related illness is the leading cause of preventable death. She teaches cooking. She teaches food sourcing. She teaches people to look at their own yards and sidewalk strips and the vacant lots on their blocks with different eyes. And every spring, when the ground warms and the rains come, and the purslane pushes up through the soil the way it always has, she brings her clients outside. She kneels. She points to the low clusters of smooth green leaves, the reddish stems fanning out across the dirt. She tells them what it is, what it carries, what it costs, what it took from the world for this information to go missing for 2 generations. Most of them have seen it before. Most of them have been pulling it out of their gardens their entire lives. The plant never left. It was never eliminated. It was never actually beaten. Every herbicide application, every generation of weed management training, every agricultural manual that listed it as a target, every year that passed without a single grocery store stocking it, and the plant simply continued. It seeded itself in soil too poor and hot and dry for anything else. It grew back the following spring. It grew in sidewalk cracks and along chain-link fences and at the edges of parking lots and in the untended corners of school playgrounds. Waiting. Not with patience. Just like the indifference of a living thing that does not know it was supposed to disappear. And that is the thing about forgotten knowledge. It does not disappear the way a building disappears when it burns. It goes quiet. It retreats into the people who still carry it, the Erlines, the grandmothers with worn notebooks and dirt-stained hands. It persists in the soil itself, in seeds that can wait decades before they find the right conditions to come back up. The history of food is not just about what people discovered. It is about what they chose to remember. What institutions decided was worth funding. What markets decided was worth selling. What schools decided was worth teaching. And sometimes the most important things get left out of all 3. Deja hands a fresh pulled stem of purslane to a woman named Tamika. Tamika is 34. She has 2 young children. She has been spending $40 a month on omega-3 supplements from a pharmacy that is 2 bus rides away. Tamika turns the stem over in her fingers. Look at it. Looks at Deja. She puts it in her mouth.